Here's the punctuated version of your text. That is the force of one of these space rocks. 10,000 Hiroshima bombs is the power pressed by this piece of genuine domain a mile across Oumuamua, a secretive element that once zipped through our planetary group and has again sent shock waves throughout the logical local area. Elon Musk, an unmistakable trailblazer in space innovation, uncovered that Oumuamua is back, and this time, it's not the only one in its excursion. Elon Musk claims that its secret qualities contain an enticing clue with respect to life in other star frameworks. This isn't the customary return of a heavenly element. It's a return that challenges our comprehension of space and its true capacity. Inhabitants, go along with us as we unwind the suggestions and secrets encompassing Oumuamua's startling return. Back in 1837, a strange object arrived at a striking infinite achievement. It crossed a distance of 1,000 galactic units from the Sun. For over a century, this item proceeded with its venture inconspicuous, consistently progressing toward our star. It was only after October 19, 2017, that mankind at long last became aware of its presence. On that specific day, a picture caught by the Pan-STARRS 1 telescope at the University of Hawaii uncovered a weak, sensitive streak crossing the sky at a reliable speed, covering around 6.2 miles per day. This undeniable moment was the first recorded interstellar guest, formally designated as 1I/2017 U1. This item was additionally given the name Oumuamua, which means a courier from afar, showing up first in Hawaiian. The disclosure ignited a worldwide drive to notice Oumuamua through telescopes. Cosmologists, including those from the SETI establishment, anxiously locked in noticing the item, in any event, sending off looks for possible extraterrestrial signals. Oumuamua looked like a ruddy, stoga-shaped object comprised of rock. Its prolonged shape is striking, extending up to 4 meters long and quite a bit longer than it is wide. Oumuamua has a viewpoint proportion that outperforms any space rock or comet seen in our nearby planet group. Oumuamua was going at a speed of 196,000 miles per hour when it drew near to Earth. That is multiple times quicker than a projectile, and that implies there's absolutely no way that this article was part of our planetary group. This time, researchers couldn't at first decide whether Oumuamua was a space rock or a comet. Comets are made out of ice while space rocks are rock. At first, researchers thought it was a comet. However, their characterization changed to considering it a space rock once it zoomed past the Sun on September 9, 2017. Anyway, they still thought about it as a space rock until extra estimations shown slight speed increases, which is an indication of it being a comet. An exceptional normal for Oumuamua was its intermittent lighting up and diminishing every 7.3 hours. This powerful way of behaving demonstrated its pivot around its short hub. Such a pivot design suggested a more unbending and tough structure than the normally delicate, snow-like material of most comets. Seeming dull red, like specific moons in the external nearby planet group impacted by space radiation, Oumuamua's tone could likewise include iron, as proposed by Dr. Meach, a space expert at the University of Hawaii. In spite of these bits of knowledge, Oumuamua's starting point and nature remain a mystery. Its direction perplexed researchers, indicating something beyond regular clarifications. Different speculations arose to make sense of Oumuamua's character. While some trusted it to be a rock, others proposed it was made out of gas. Incredibly, a subset of specialists even engaged the likelihood that it could be an extraterrestrial space apparatus. This raises the charming question: could an extraterrestrial mothership be exploring our sunlight-based framework and conveying more modest tests to investigate planets? In the resulting section of this video, we will dig further into these secrets. However, first, we should inspect the scope of logical suggestions that have been advanced to interpret the beginning of Oumuamua. Dr. Meach proposed the thought that it could have been flung out from a far-off star following a cosmic explosion blast or maybe shaped at the point when two particles impacted and melded. According to Elon Musk, space experts were at first invigorated when they noticed that the direction appeared to highlight Vega, the splendid star in the Lyra star grouping, known to have a trash plate. Estimations demonstrated that this element might have headed out from Vega to our area in around 600,000 years. However, the probability of Vega being the genuine source has lessened because of massive changes in its way. It's accepted that Oumuamua experienced another star framework interestingly, taking into account its movement about the Sun, which was similar to the speed of adjacent stars. In any case, there's plausible as suggested in nature that Oumuamua could have been traveling around the universe for billions of years. We're questionable about its impending direction. Imagine it like this. Recall how the Voyager shuttle got a boost in speed from Jupiter? Well, Oumuamua is likewise acquiring energy from the Sun, pushing it quicker and somewhere new. Dr. Meach explained this space rock, along with its partners, reforms our perspective on the world. Picture this: when you gaze toward stars appearing to be far off and secluded, it appears differently in relation to what these space rocks divulge. They advise us that things are interconnected and charming. The oxygen and iron inside our blood rose up out of a gigantic blast in a far-off spot quite a while ago. The brilliant things, like wedding bands, came about due to the crash of superdense stars and those shooting stars plunging to Earth. Some of them began from Mars due to space rock influences. Astoundingly, some regarded researchers mull over that these shooting stars might have conveyed life from Mars to Earth during a time when Mars delighted in warm and wet circumstances. Life could have started there and then caught a ride on those shooting stars to Earth. It's a daring idea, but it's being considered by regarded cosmologists. Our association with the universe can be tracked back significantly further in time. Ponder the countless years Oumuamua could have taken to show up here. While that could appear extensive, it's just a brief moment on the vast scale. The Milky Way galaxy brags an age of 10 billion years. Over this massive time span, Oumuamua could have ventured through around 20,000 star frameworks. A humble part contrasted with the galaxy's 200 billion stars. Yet, still a critical number of inestimable experiences, Oumuamua would have followed behind residue and flotsam and jetsam, permitting the stars and the universes of the cosmic system to mix. This recommends that the universe may be more modest in scope than recently thought. Regardless of whether it's no longer inside our nearby view, the Nearby Planet Group hasn't relinquished it just yet. Elon Musk and different space experts foresee that Oumuamua will enter the Kuiper Belt around 2024 and cross its edge by late 2025. He likewise appraises that it will pass Jupiter's most far-off point in 38 years. However, since Oumuamua has been far off for space experts, they are taking advantage of the data assembled in only a couple of months to appreciate as much as possible about this captivating interstellar gatecrasher. At first confused with a space rock, due to its size of around 2,600 feet long and 260 feet in width, Oumuamua showed whimsical behavior in its direction. Stargazers and researchers noticed a prominent non-gravitational speed increase, showing that forces beyond gravity were impacting everything in its movement. Dr. Meach made sense of that several variables could lead to this speed increase. Her group researched at least 6 potential causes, disposing of some due to their improbability or irregularity with perceptions. One likely clarification was comet outgassing. A typical event in comets, outgassing happens when a comet approaches the Sun and its surface ice supplements diverting straightforwardly from solid to gas. This cycle gives the comet an extra push, adjusting its speed and turning past gravitational impact. This adjustment of movement looks like the behavior of Oumuamua, lining up with the power seen in comets. Note the absence of a rising dust from Oumuamua was charming. Commonly, as gas leaves a comet, it conveys surface residue with it. However, Dr. Meach affirms that regardless of whether the comet lacked tiny material, the likely presence of significant dust on its surface could have been influencing its speed. This thought kept the possibility of it being a comet alive. Moreover, researchers fundamentally analyze apparent frequencies, which make it challenging to identify critical dust particles. Thusly, no apparent proof of residue leaving Oumuamua was noticed. The shortfall of gas-related signs was likewise confounding. Shockingly, cosmologists expected a recognizable measure of gas emanation to impact Oumuamua's speed in the way noticed. Dr. Meach's group explicitly looked for CN gas, a substance that she notes is brilliant and without any problem recognizable. It fills in as an intermediary for water, which is more challenging to screen since CN is frequently let out of comets in our planetary group close by water. Intriguingly, despite their endeavors, no CN gas was distinguished within their discovery limits. Taking into account that comets in our sunlight-based framework can hold critical measures of water, areas of strength for the breaking point set by the non-appearance of CN gas demonstrated that this comet was chemically remarkable. Dr. Meach makes sense of that. If a huge volume of water were present in Oumuamua, it should have delivered a detectable amount of CN gas as it dove through the solar system. After careful analysis, Dr. Meach's gathering wound up at an impasse. The straightforward version is this: they realized something about Oumuamua, but had no idea what it was. There are numerous reasons for this puzzle. It wasn't as a result of the traditional ways we connect with space. Many experts considered that since this article emerged from space, they had no need to give it a name like we typically do with a comet or an asteroid. If Oumuamua resembled nothing we could think about, that additionally influenced scientists' understanding of space travel. Some could even propose it wasn't something we could equate with from our planetary group. Yet, despite these advancements, the speculation surrounding extraterrestrial intelligence remained. The chance of Oumuamua being an observational satellite prompted discussions of the components that could emerge. This added significant effect to the thought, making sense of how such items could be fabricated or built. The thrill of scientific investigation was awakened by the notion that Oumuamua could be a spacecraft sent to collect knowledge from our sun or to communicate with us directly. Elon Musk additionally implied that the curiosity surrounding Oumuamua isn't simply an isolated event. It underscores our quest to grasp our universe. We're at the cusp of an extraordinary new beginning, attempting to answer those profound inquiries. Are we alone in the universe? Could life have emerged in the stars? Even though we await its future appearance, Oumuamua has firmly secured its position in the history of astronomy. It has challenged our expectations of interstellar objects and reminded us of the unexplored mysteries within the universe. And though its secrets remain unsolved, we can take hope in the fact that humanity's thirst for knowledge will only grow as we continue our journey through the cosmos.